All right, this is ITS128, and today is September 29th. And let me share my screen. All right, so if we look at our syllabus, Lima. Okay, let me put up my, okay, so let me put up the chat. Where's the chat? Security, polls. Click this. I can't find my chat. Oh, there it is. Boy, they keep adding stuff to this. Okay, so today I'd like to, since we're so far ahead, this is September 29th, we're in this week. And the thing is we've already finished all these. We've, class number 10 here, if you look at that video, that does, I think, the last couple or something like that. And class number 9 does these, and class number 8 does the challenge activities and so on. And so a couple of you have asked me to go over some problems today, and I'd like to put it out there for everybody. So today and probably Thursday, I'd like to do some reviewing. And if there's some things that you have questions on, for example, if you have some problems, challenge activities, or some lab assignments that you've got, even ones that you've gotten all the points for, but you don't quite understand why you got all the points, or you're not getting all the points, and you want to know why, I'd like it if you could post them up on the chat here, and then I will I can do them today in class. Now there was one, find that one. Okay, one person had a problem with the leap year program. I'll do that one, 4.16. Okay, I'll do that one. Let me pop that out. And someone else had a one, which was, I sure get a lot of mail. Hold on a second. All right, so the first one, somebody asked me to do last week, 3.1.2, I think. So let's do this one first. Right. Okay, so phone. Okay, yeah, that's right. There was a couple ways that we can do this, and the idea is you enter in this 10 digit thing, or you could even look at it as a 10 character thing, and just 10 symbols, or you can look at it as a huge 10 digit number. Those are a couple of ways of interpreting that string of 10 digits. But however you interpret it, you want to read in something that looks like this, 10 digits in a row, and you want to output something that looks like this. A left parentheses, followed by the first 3 digits, followed by a right parentheses, followed by a space, followed by the second 3 digits, as digits 4, 5, and 6, followed by a hyphen, followed by the last 4 digits. Okay, so you want to display something that looks like that. Now, if you read this, given an integer, okay, so that kind of leads us to think that they want us to look at this as an integer. I think what I did last time was I actually treated it like a string of 10 characters, and I showed you how you could, divide it up and display out this stuff with just a string of 10 characters. But that might have been why some of you are confused. And I gotta make sure that you sort of get the basics first before I start getting fancy and start telling you all these other ways that you can look at the problem. Later on, we can look at other ways. But so let's take the integer approach. It's a 10 digit number, and it looks like that. And so what you want to do is you want to grab out the first 3 digits, the second 3 digits, and the last 4 digits. So here we're inputting the phone number like an integer, and we want to output something. Okay, so we want to have something like first 3 digits. Oh no, let's just call it area code. Area code equals something, and we'll get to that. Tell you what, let's do this. 808. Oh, let's do this. Yeah, 800. Sorry. And then we can say the exchange. Is it the exchange? That's called the exchange, right? The next 3 digits. Does it tell us that? The prefix calls it the prefix. Prefix equals 555, and what do we call the last 4 digits? Line number. What do we call it? Yeah. All right. Line number equals the last 4 digits. Now, I'm just putting these here just to show you, okay? We're going to actually have to calculate this from this, okay? But I'm just going to do this now just so we can see what the right answer should look like, okay? So once we have that, then we want to print this. We want to print it so it looks like this. So we can do it this way. We can do we can use formatting. How would we use formatting? Well, let's not use formatting. Let's say output. I'm going to call it output equals. First, we're going to have that left parentheses equals that. Plus, remember, we're concatenating strings. So we're treating these not as numbers, we're treating them as strings. So it'll be area code plus the ending parentheses and a space plus the prefix plus a hyphen plus the line number. Okay, and then if we print this, it's going to look like this. So I'm going to do this. 8. What is it? 5551212. Oh no, no hyphens. So if we run this program, it's going to look like this. Obviously, it's going to look like that because we're just printing that directly out. If we make this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, it's still going to print it out as 808 555 1212 because we're printing that out directly exactly. We want to instead be printing out this is the area code, and we want that to be printed here, and this is the how you say prefix, and we want it to print here, and this is the line number, and we want that to print here. See, so let's figure out how to put we read in the phone number, and now we put the area code here, and we put the prefix here in the line number here. Okay, so I'm going to start out with where I have this number. I wonder if it would help if I brought up Excel. Let's see if I can bring up Excel for a second. I have a lot of time today, so Excel. Can you do the mod operation in Excel? I don't think so, actually. Equals 10 mod 2. No, it doesn't take the mod. So how do you do mod? I'm going down a little tangent here. Oh, mod. Oh, this is how you do it. You have to do it this way. Really? Oh, it's just this. Okay. So you got to do, instead of 10 mod 2, oops, you do, so instead of 10 mod, I'm going to do 3. 10 mod 3 is the same as equals mod 10 comma 3. Yeah. Yeah, right. If it's 2, it's maybe. If it's 4, it's oops, yeah, 4. Yeah. Anyway, forget this idea. That'll be too confusing for you if I continue down that path. So if we have a 10-digit number like this, and we just want the first 1, 2, 3, then we want to basically hack off 1, 2, 3, 4, 5, 6, 7 digits. We want to hack off the right 7 digits. So we can do that by going area code equals phone number, this kind of divide, and then a 1 followed by 7 zeros. Okay. Now I'm going to bypass this here, and I'm just going to say, well, that's okay. Let me do this. Print phone number. Okay, so I'm just going to print that out just so we can see what we read in. And then I'm going to compute this. And what this is this divides phone number by 10 million. And if we divide the phone number by 10 million, it's like 1.23.4567890. It's like, normally when it's like this, if we divide by 10, okay, that's what the number is if we divide by 1. If we divide by 10, we get this, because we're dividing it by 10. If we instead divide by 100, we get this. If instead we divide by 1,000, we get this. We divide by 10,000, we get this. We divide by 100,000, we get this. Oops, forgot the 6. If we divide by 1,000,000, we get this. And if we divide by 10 million, we get this. Now, if we divide by 10 million like this, then that's going to give us a floating point number. It's going to give us 123.456.789. We don't want that. We just want the integer part. We want just the part that's to the left of the decimal point. And to get that, we use the double divide. The double divide is an integer divide. It divides it just like the regular divide, but then it hacks off everything to the right of the decimal point. It discards everything to the right of the decimal point. So this will give us the 1, 2, 3 part without any of this, without anything else. So so if I run this, it's going to look like this. Oh, never mind. The problem is this is like a number. This ends up being a number, and what we want to have here is a string, because we are using this. We're treating all these as strings. Well, it's easy to do that. We can just do string. I believe we can do this string. I think we can do that. Let's see. Ah, yes. Okay. So this executing puts this inside this variable. This executing prints out this 10-digit number. You notice it's a number. It's not a string of it's not a string of 10. It's not a string of 10 characters. It's a 10-digit number. But when we printed it out, it knew that really we wanted to print out a string. Okay, so this is actually a string that comes out here, but we're printing out a number. So this is an example of where we did not have to do this. We did not have to do this. So, you know, most of the time you have to specify exactly if you're doing a conversion, but sometimes you don't, and this is the time you don't. So this should give me the same thing. Let's see, but it is relaxed in this case where we don't need to do that string conversion. Okay, and then here we take the phone number, which is this, as a 10-digit number, and we do an integer divide by 10 million, and we end up with just 1, 2, 3. And so that's why when we run the program right here, area code gets equal to 1, 2, 3. But the prefix is still 555, and the line number is still 1, 2, 1, 2. So when we come down here, we print the left parentheses, we print the 1, 2, 3, which comes from here. But then this stuff here is still these things. Okay, so let's figure out what the equation is, or what the assignment statement is, to figure out what the middle. I'm going to put this. I'm just going to put this here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. I'm just going to put that there so I have the reference up here. It's inside the comments, so it doesn't matter at all. So how do we get the 555, 1, 2, 1, 2? Well, we have the 1, 2, 3. Actually, we have the whole thing. Let's go back to the whole thing, and let's instead of using an integer divide by 10 million to hack off the lower 7 digits, is that right? 1, 2, 3. Instead, let's do a mod operation to hack off the upper 3 digits. Let's hack off the upper 3 digits. So what we have left is just the 4, 5, 6, 7, 8, 9, 0. So to do that, I'm going to do prefix line number equals, let's take phone number, which in this case, in our little example here, is going to be 1, 2, 3, 4, 5, and let's do a mod. Oops, mod. What's going on? Mod 10 million. And what that's going to do is it's going to give us the remainder. It's going to give us. Oh, that's where it went. It's going to give us. It's going to divide by 10 million, which is going to equivalent. It's going to give us this. but it's going to just take the remainder, and the remainder is this part. So let's print this out just to see what it looks like. Prefix, print prefix line number. And again, in this case, prefix line number is a number. It's not treated like a string. It's not a string of characters. It's an actual 7-digit number. But in this case, we can print out a 7-digit number, and it knows that really what we want to do is we want to print out 7 as though it's 7 characters. I hope that's not confusing to you. So anyway, so when we run this one now, we get here. Now we have the 4, 5, 6, 7, 8, 9, which is this part. So the area code is still this. It's still this part. But now, we printed out the last 7 digits, which is this. Okay, so we don't want the last 7 digits. We want the upper 3 digits of the last 7 digits. So let's use this and do the same kind of thing that we did up here, except for we aren't going to divide by 10 million. We're only going to divide by 10,000, because in this case we want to hack off the lower 4 digits. So it's going to be prefix line number integer divide 10,000. 4 zeros. 10,000. So that's going to be prefix. Now we have to make this a string. In fact, you know what I'm going to do? I'm going to take the string off of here, and I'm going to put the string down here. String. I can do this. That way, that way everything above it, I'm treating them all as integers. And it's not until I get to the output here where I actually convert them into strings of characters so I can print them out, and so I can do this concatenation operation here. So let me do string prefix, whatever that is, and string line number. And it's okay if you convert a string to a string. I think that's okay. I don't think it's going to cause any problems. Line number is already a string, and then here I do string of line number. I think that's okay. Let's see if it's okay. I'm gonna so now I've converted prefix into the lower 7 digits, and then I've hacked off the. This is the lower 7. This is the lower 7 digits of the whole thing. In other words, it's this. And then when I do this, I'm hacking off the lower 4 digits. So I hack off this, and I end up with just this 4, 5, 6. So when I run this one now, prefix should equal the 4, 5, 6, and so this should end up being 4, 5, 6. Let's see. Okay, there we go. 4, 5, 6. So this print statement is this, and then this print statement is printing out this, and then this print statement is printing out this mess right here. Okay, so anyway, we're close. Now all we got to do is hack off this lower 4 digits. Well, we can do it the same way that we did it up here when we wanted to hack off the lower 7. So line number is actually prefix line number mod 10,000. I think this will work. Okay, so there we go. So we take this number. This number is printing out what we read in. It reads in the phone number, prints out the phone number. That's reads in this phone number, prints out this phone number. And then we calculate what the area code is. And once we calculate the area code, okay, so once we have this phone number, the area code is the upper 3 digits, and prefix line number is the lower 7 digits. So this hacks off the lower 7 digits, and it just leaves the upper 3 digits. And this is going to hack off what's ever above the lower 7 digits. I mean, in other words, that's the area code. It's going to hack that off, and we end up with just the 7-digit phone number. And so when we print just that 7-digit phone number, that's this thing that we're printing. Okay, so this is a 7-digit phone number, and then we're going to do the same thing again. We take the 7-digit phone number, and we want to hack off the lower 4 digits. This hacks off the lower 4 digits, and so this prefix is going to be whatever the 7-digit number is with the lower 4 hacked off. So it's going to be this with the lower 4 hacked off. So these are going to be hacked off, and we end up with just the 456. So the prefix is now just the 456. The 3 digits that are left over from hacking off the lower 4 digits from the remaining 7 digits after hacking off the top 3. Anyway, so this, we have prefix line number, and we want to split them up into the upper 3 and the lower 4. In other words, you want to hack off the lower 4, and we want to just keep the lower 4. So this is hacking off the lower 4, and this is just keeping the lower 4. So so this is just going to be the lower 4. Now this integer divide and this modulo operation, where we're working with base 10, we'll just powers of 10. This works with when we're dealing in if we have 10, we have digits that are base 10 digits. We can do this hacking off below, hacking off above by just doing integer divide by the number, by this 10,000, which is going to be the 10 lower 4 digits. That works. It actually works with any base, but since we do all of our math and we do all of our when we represent numbers, we use base 10. It doesn't end up being so easy. So these are just some tricks that we can do if we're dealing with base 10 numbers, and all we want to do is hack off the bottom or hack hack off, or we want to hack off the bottom or hack off the top. So anyway, now to actually get the correct answer, we need to get rid of these extraneous print statements that we threw in there just for testing. It's a good idea to throw in these extra print statements just to see what's happening along the way, because you might think something is happening, but then you throw in the print statement and go, oh no, that's not what I meant. I meant the other thing. And so these little things where we put in all these extra print statements. Now you can delete them or you can just comment them. Commenting is a hashtag, right? Yeah. Now we can comment this, and really all we need to do is leave this. So when we run the program now, we get just what this is. And so, and if we put this number here, copy, we put it here, and we run this, then we get the right answer. We get this answer from this, which is what it shows up here. This answer from this. Okay, so the person that asked me this question can get back to me if it's clear, or if you'd like me to elaborate a little more, and I'm happy to elaborate more either next time or this time, or we can have office hours.
I got it. Thank you.
Good, very good. Okay, so another one that someone was interested in is this one here. Okay, let me just copy this code here. And what was the 4.5.1? Let me go here. 4.15. Oh yeah, exact change, right? Exact change. So and this is the code. This was the code. What happens if I paste this here? All right, here we go. Here's the code we were looking at, and I'm just gonna go through and I'm gonna explain what all this code is. Okay, so in this problem, it's kind of the same idea, except for we're not just in the other problem. We're dealing with just base 10 and hacking off lower digits and upper digits, but in this, we're going to use this mod, the integer divide and the mod operation again. But we're going to do it successively, like we did before. But the divisor is the number on the bottom. The dividend is on top, and the divisor is on the bottom. And you divide a dividend by divisor, and you get a quotient and a remainder. And so we're going to be doing those operations again with this. But the first time, we're going to do the operations with where the divisor is 100, because we're going to dealing with dollars. This is all cents, right? It's all pennies. It's all cents. So we want to take the original number, and we want to take the integer divide by 100, and that gives us the number of dollars. Let's what happens if I pop up my little thing here? Okay, so if we start out with $1.23, and we want to see how many dollars, quarters. Let's do a better number. Let's do $3.72. Okay, well, and so we're seeing this as $3.72, but let's think of it like 372 cents, 372 pennies. Okay, and we want to figure out how many dollar bills, and then after we've done all the dollar bills, we're going to have 72 cents left. We want to figure out how many quarters, and then after we figure out how many quarters, there's going to be 2 of them. We're going to be left with 22 cents. Then we figure out how many dimes, and so we have 22 cents. We're going to divide that by 10. We get 2 dimes. We're left with 2 cents. We try to do nickels. No nickels will fit because there's only 2 cents, so 0 nickels. And then what's left over that is the pennies. So first we do dollars. D. Dollars is hacking off the lower 2 digits. Dollars equals, so I'm gonna call this starting. I'll call this yeah, dollars. I want dollars, quarters, dimes. No, I'm going to do T for dimes. T's short for 10 cents. How's that? T for dimes, and N for nickels, and P for pennies. Okay. And so for dollar, and I'm going to call this the starting number. Because we enter this, right? Oops. So we enter this. So I'm going to call this S. Oops. S equals, and I'm going to get rid of the thing because when we enter, oops, because we're entering in a number here, the 45, and then we enter it in as pennies. Yes, we're entering in as cents. Okay, so we start out. So let's do a bigger one. We're going to start out with 372. So it's $3.72 change, or 372 cents. So to get the number of dollars, we divide S by 100, and that's going to give us 3. S, integer divide 100, S is 372. That's going to equal 3, right? But I don't want to confuse you, so I'm not going to put that there. And then we can have an intermediate. We can have an intermediate thing, or we can just use. No, we're not going to use S. I'm going to say leftover. This isn't going very well here. Left over equals S mod 100. Okay, so D here is going to equal 3, and I can do a comment. Equals 3, and left over here is going to equal the lower 2 digits. So here we're doing S integer divided 100 gives us the 3, and then S mod 100 gives us the 72. Does that make sense? This looks terrible. Okay, anyway, I'll do a different color now. Okay, so we got the number of dollars, and we have leftover, and leftover is equal to 72 here. And so now we want to see how many quarters, right? Quarters is next. So quarters is equal to leftover slash integer divide 25. So 72 divided by 25 is going to be 2 point something, but it's just the 2. So this is going to equal 2 because it's 2 quarters going to 72. 2 quarters, and then the new leftover is the old leftover mod 25, and so that gives us the Q, and then and so we have figured out how many quarters. There's 2 quarters go in there, and so what's left over? Left over now is equal to 22, because 72 mod 72 mod 25 equals 22. Why? Because 25 divided by 72 is going to be 2. 2 times 50. 72 minus 50 is 22. That's it. So 25 doesn't go into 22. So 2 is the dividend and 22 is the remainder. No, 2 is the quotient and 22 is the remainder. So it's 2 quarters. That's the 2 quarters because 25 is quarters. So, and this is leftover. And so we have 72 mod 25 is the remainder. This is the mod. What's left over at the end is the mod, and what's up here is the quotient. So this is the slash. Hope that's making sense. And anyway, so that gives you 25 cents, and then next you have 22 cents, and you divide that by 10. You want to find out how many dimes go in there. Well, it's 2 dimes, and you left over with 2 cents, and so after that you try a nickel, and then there's no nickels and 2 cents, but then there's 2 pennies and 2 cents. So if we want to sort of summarize something else that I want to summarize this. How do I get rid of that? Oh my! Let me just. So if we have dividend divided by divisor equals a quotient and a remainder. Okay, so if we have 27, we have 27 is a dividend, and the divisor is 5. The quotient is let's do a better. It's confusing. Do a different number. 37. 37 divided by 5. 35. 37. We get 6 times 5. 7 times 5. 7 times 5 is 35. And what's left is 2. So this is the quotient. This is the remainder. This is the dividend. This is the divisor. So this is dividend. This is the divisor. It's helping much. I'm not that good at chalkboards. But anyway, so when we have something like this, in math terms, if we have 37 divided by 5, the quotient you get the quotient using //5, because this is the 5. You get the remainder by using mod 5. So if this is what you're trying to figure out, 37 is the dividend, 35 is the divisor. And to get the quotient, you do 37 integer divide 5. And to get the remainder, you use mod 5. All right, so that, I don't know if that made anything more clear, but let me just put this down and let's go back to this code here. That actually wasn't the issue that this person had, but that mod thing was an issue somebody else had. So I kind of wanted just to go over the mod because this is a great example of where mod, integer division, in the modulo operation is exactly what we use to figure out the answer to this. So the problem here is what happens when we run this? We're supposed to put in some number like 45. So let's put a 45 here. And when we run it, we end up getting a bunch of stuff. Let me submit mode, and we run it. And we end up getting a bunch of extra stuff here. And and so what's good about this problem as an example is it's a lesson on how to use this, what I think is kind of a dumb system for helping, to assisting in our learning how to code, because it's not clear when you enter in some code where it actually shows up and what's the issue here. There's these, it's shaded and everything. So if we look at this closely, and there's some of you that some of this might be boring to some of you because it finally clicked. But there's still people that didn't click. So I want to try to bring everybody. Okay, I want everybody to get a good grade in this class. Okay, I do. I want that. So sometimes we're going to have to step back. And for those of you who this is very clear already, we'll just sit back, and this will reaffirm your mental model of what's going on here. The problem here is the yellow words. The yellow should not be there. So there's two problems here in this particular example. One is there's a bunch of extraneous stuff. It doesn't need to see any of this, and it doesn't need to see this S here because it's only 1/4. It's not 1/4. It's 1/4. It is 2 dimes. So yeah, we should have the S here, but we shouldn't have the S here. Here it's and then the other problem is that this displayed out. For this here, it would have been correct when the input 0, except for this here displayed out. Okay, and then for here again. So this stuff here, when it says enter the amount, that's just something that I threw in there because when we run this on I guess I don't really, they tell me that I should not encourage you to write your code So if I were to run this from here, the command prompt, I like to see this. I like to know what the heck the thing's asking me. Okay, so I make this thing display out. Okay, that's what this is right up here. That's all that is. Well, it doesn't like to see that. It doesn't like to see that. So to fix that, we can just take this out. If we take this out, then there's no prompt. Yeah. Take this out. Then there's no prompt. I save this. Now the problem is if I run it, okay, I'm going to run it. It's just sitting there. Well, what do I do? Well, I guess I'm supposed to know that I'm supposed to type in a number. Okay. Oh yeah, I guess I had to type in a number. Well, you know, I don't see that to me that's confusing. To me that's not good coding, and it's so easy just to put that prompt in there. So that, by the way, the person that asked me that asked me to do this, it's all that you're printing out some extra stuff that you shouldn't be printing out. Oh, and then there's the plural, singular plural thing. I'll get to that. But when I'm doing these things on TV here, I like to put in extra stuff. Just I put in a lot of extra stuff just so we can see how things are going, just to see how calculations are being made along the way. We can see the intermediate values of the calculations, but also when my program is asking a user to enter something, I like to tell the user what I'd like the user to enter. I don't want to just, you know, I don't want to just do this, you know, and the user is supposed to know, oh, I guess I'm supposed to type something in now. Let's go back here. Let's go. So, okay, we're supposed to print this out, but we're not supposed to print this out. See, this was the other thing that I didn't like. Oh, I'm sorry, wrong language. I'll just take it out. So that was in there just so I could see, you know, here, see it. You know, I just want to see that it got it. Okay, I type in a 57, and I just display this out just to see. Okay, it took 57. It's going to start with 57. Just information for the user. Well, it doesn't like that. Here, I'm going to leave it in there for a second. Let's run this. Okay, see, it doesn't like this 45 starting value, blah, 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 blah. So it just doesn't like that. So let's take that out. And now when we run it, now what it doesn't like is when there's only one of something, we should not have it be plural. It should be singular. It should be 1/4, not 1/4. 2 dimes is okay. Here we've got $1. It should be dollar, not dollars. Oh, this is not quite right. We should never have. So we'll fix that too. You know, in this case, we should never have some number of something. Well, 6/4 is $1.50, right? We should have taken out the $1 worth of quarters there. So we'll fix that too. All right. Oh, pennies instead of, okay. So let's fix that. So here we have some dollars. Let's start with this. We have this input value, and we want to figure out how many dollars it is. So we want to do this integer divide by 100, and we want to keep everything to the left. You know, so we want to hack off the lower 2 digits and keep the rest, and that'll give us a number of dollars. And then what we want to do is we want to have a new input value here that has the number of dollars subtracted out. So here we have the old. Takes the old input value and it subtracts out the number of dollars. Well, our error here is that it should be the number of dollars times 100, and not, you know, not mod 100. So like if we have if we're starting out with $1.56, then this, let's say we start out with the dollar. Okay, I'm going to get rid of this. It's not supposed to have that there. But let's say we start out with $1.56. Let me just do an example here. let's start out with 156. So this is going to give us, this is going to hack off the lower two digits. So this is going to be left with 1. So num dollars in this example equals 1. And now we have this input value, which is 156, and we want to subtract off 100, right? We want to subtract off 100. And so here we take the number of dollars, which is 1 times 100. And this number is the same as this number. See, this like divides it out. And then this kind of, you know, computes what the value of this is in pennies, I guess. So this is going to leave us with input value. Input value is now equal to 56, because we took 156 and we subtracted 100. 156 minus 100 equals 56. So that's what's left. Okay. It's taken me a while to get to this thing about dollars and dollar. I would do something like this. If num dollars equals 1, then print num dollar. Otherwise, if num dollars is greater than 1, then print num dollars, comma, dollars. So, and if it's 0, it doesn't do anything. You don't want it to do anything. Oh, yeah, right. You don't want to do anything, do you? No, you don't want to do anything. So let's fix this here. Excuse me, times. If num dollars is greater than 1, so we want this to be equals 1. And this is going to be greater than 1. Then we want it to say, oops. Wait a minute. Did I do that right? Yeah. Want this to be num dollar and this to be num dollars. Okay. So, so now if we do, let's run this. Oh, let's just run this. Submit for grading. I must have forgot a colon. Oh, I really messed this up. Else, this should be else. Oh, elif. Elif. Right, this should be elif. Elif. So what happens when we run this now? Did it work? Line 12. Line 12. I thought I... Is there something... Well, anyway, let's try this. 145. No, it's 245. 245. $2. Great. 145. $1. Okay, but 1/4, that would be wrong. So, let's see if this is right. That's good. Yeah, right. See, so this is the shortcut way of doing it. This is the long way to do it. If you want, you can get rid of this. You know, you can do minus and get rid of this. It's exactly the same thing. This minus equals means input value equals input value minus num dollars times 100. It's going to do the multiplication before it does the subtraction. Okay, so that works there. And so then we do quarters. We have converted input. So we've taken this original input value of whatever it was, 145, and we can figure out how many dollars is in there, and then we subtract out that amount. We subtract out the dollars amount, and we end up with just, the cents. And then we take that and we figure out how many quarters are in there. So this is going to tell us how many integer integer quarters. We don't want a fraction of a quarter. We want the whole quarters, how many whole quarters there are. So if it's like 56 integer divide 25 is just 2. So this would be 2. And then here we're taking the same value of 56, and we're taking mod 25. So that would be the remainder of the input value divided by 25. So if we're talking about the number 56, and 56 integer divide 25 is 2, and 56 mod 25 would be the remainder of input value divided by 25, and so the remainder would be 50, or it would be 56. So are we subtracting? We have to subtract that out again. Okay, so number of quarters equals input value mod integer divide 25. So we got the number of quarters, and wait a second. Wait a second. This is one way to do it. A better way to do it is input value, which is, what did you have originally? Oh, I see. Value equals input value mod 100. Yeah, that does the same thing. This is going to take, okay, let's say we're starting with 156, just for the sake of, let's say we input, let's say we input 156 or something. This is going to equal 156 integer divide 100, and that's going to equal 1. And forget about this for the moment. Guess I better put the comment here. This is going to take 156 mod 100, which is going to hack off the 1. This is going to leave us with the lower 2 digits of this. So Okay, so that's what that does. This up here actually takes the number of dollars, multiplies by 100, and subtracts that out. So that's just another way of doing it. This to me is more elegant or cleaner, because here we're dividing, here we're modding. Then we're going to divide, then we're going to mod, then we're going to divide, then we're going to mod, and then we're going to divide, then we're going to mod. So let's do it that way instead, just because it's more elegant. I hope I'm not confusing you more. One of the main things I want you to get out of this is there's just always many ways of doing it, and people start to have their preferences. You're going to start having preferences in sort of which way you do it, and you're going to want to keep with the preferences because that's how you think about it in your head, and you've already figured it out that way, and continue to do it that way. We can, let's equals 1 quarter Okay, that should take care of quarters. Here's dimes. Okay, so we had that part here already, and then this is nickels. So you can do nickels. Okay, I've done dollars, quarters, dimes. You can do nickels. This is not gonna. This is only gonna do. This is always gonna say nickels, whether it's one nickel or many nickels. So you can fix this so it looks like this, and pennies too. You don't need this, because anything mod 1 is itself. You take 25 mod 1, it's just 25. It's like, oh, never mind. Ugh. What is mod 1? Something, what's the remainder? If you divide something by 1, what's the remainder? It's 0. It's always going to be 0. So, but it doesn't matter because we're done with the input value anyway. Did I put this in my lesson when I was doing this? Yeah, we don't need this at all because this is the last time input value is used. In fact, we could probably put num pennies there, and then we wouldn't need either of these two, but just to be consistent. But anyway, we certainly don't need this because we never use input value again. But anyway, you have to do the same thing for pennies. So let's see what this does for us. Let's run it first. Let's do 147. Why is there such a space around here? So it should be okay. So okay, right. Let's see what this does. Okay, so we still have this. We haven't fixed the pennies yet. Let's see. Yeah. Okay. Anyway, so if we actually submit this. What? Now that is confusing me. Why? Is this a bug in the 427? How to fix this? Line 12. It does something. Doesn't like something about this.
Last time, you for the graded part, you put 0 instead of 1.
Where, you mean like here?
Yeah.
Oh, yeah, right. That's I was being that's kind of the same thing I did here, and the same thing I did here. This just says if there's more than one nickel, then print out the number of nickels and put the word nickels after it. This is if you have more than if there's more than one. If there's any nickels, at all, then we print out the number of nickels followed by the word nickels. And the issue here is that if there's only one nickel left, then you don't print out nickels, you just print out nickel. And so, see, this covers, this is the same as if number of dollars is greater than 0. But it's actually doing more than that because it's distinguishing greater than 0. 1 is greater than 0, and greater than 1 is also greater than 0. So we want to be more exact. So instead of just having, like here, if the number of nickels is greater than 0, just print out the number of nickels and the word nickels. That won't be correct if the number of nickels is 1, because we shouldn't print out the S then. See, so this is kind of an expansion of if num dollars is greater than 0, then print num dollars dollars. Okay, so this is what I had before. Let's see what this looks like. I'm gonna comment this out. So this is what I had before, and when we submit this for grading, we run into a problem when the number of dollars is just 1. We don't run into that problem here because it writes. See, it's always writing dollars, no matter if there's 1 or more than 1. And so what we want to do is we want to distinguish. If it's only 1, then we want to print out, dollar. However, if it's greater than 1, then we want to print out the S. And we would comment this out then. We don't need this. What's happening? Are we still getting that error? Why is this taking so long? Well, that's really strange. This thing is not perfect, I guess. It's gone nuts. I better copy this out. Copy this out because I don't want to lose it. Copy. And I'm just going to do this. All right, submit. Okay, so it looks like it's fixed all the way down to nickels and pennies. So 156 should be 1 nickel and 1 penny, and instead it's saying 1 nickels and 1 pennies. Also, there's an extra space there. I can get rid of that extra space by getting rid of this thing. All right, so yeah, what you just somebody just very cleverly pointed out that it's actually okay to do this. It's actually okay to do this because oh, in fact we did that here because these two together will never happen. It'll never be num dollars is equal to 1 and num dollars is greater than 1. It'll never be. So because these ifs are going to be mutually exclusive. In other words, it'll never be the case that both of them are true. Then we don't need the else. What we had was if this is not true, then consider this. But if we take this out, it's going to say, consider this. If it's true, print it. If it's not true, don't print it. Then consider this. If it's true, print it. If it's not true, don't print it. And the thing is since they'll never happen both at the same time, then it ends up being fine. So yes, this will work. This will work. I'm looking at my chat over here. So so for you, so if you've gotten this far, then all you need to do is, just like we've done here, you need to do the same thing for nickels and for pennies. All right. So I guess we're out of time. I didn't get a chance to do. I didn't get a chance to do one more that I was going to do regarding the mod operation. The mod operation is actually confusing to people. I remember when I first learned about the mod operation, the first language I think that it ended up in, it was a language called Pascal, which used to be the language that we would teach courses like this in. Back in the 90s, the language of the day was called Pascal. We didn't have objects, but we had all these if then else things. We had the same kind of language structures. We just didn't have the object part. So in other words, we aren't into methods yet, but in languages today, when we write subprograms, it's nearly always connected with an object. So subprograms are part of a larger object, and the objects store both data and have little programs that operate on the data. But anyway, mod first appeared in that language, and it was confusing. It was confusing for me because there was all the languages before Pascal, Fortran, Basic. There's other ones, PL1. These other ones didn't have a mod operation. It just had divide, and you had to do it like what I did originally, where you have to subtract out the dollars, where you compute the number of dollars times 100 because you want the value to subtract out. And remember, that's what I did earlier up at the top. Anyway, so you're seeing me now, and you're not seeing my screen anymore. If you have any more questions, I think I'm going to do something similar to this, but maybe I'll try to be a little bit more organized on Thursday. And so if you have problems that you'd like me to cover in class on Thursday, why don't you email me, and I can cover them in class, or I have office hours before this, and I can help you then or any other time. It's pretty easy. I'm pretty flexible. Tuesdays and Thursdays I'm pretty free, but I'm actually free every day. I can find some time to meet if you need to. So we're way past time. Are there any more questions? So I think I'll end the meeting today, and I will see you on Thursday.
Oh, I have a question.
Yes.
Yeah, I don't know if people want to stay overtime, but could I see your code for the problem that we just did? Because the amount that you put in, as you go through it, right? So let's say the amount that you put in was $2.25, right?
Mm-hmm.
Now, if you write your code properly, it would output $2.01.
Yes.
But um, if you don't know how to work around that, it'll print $2.05.
Oh,
Do you know
okay.
what I mean?
Yeah, and yeah, you would, if it did that, you would have not done this part. So let me say, let me put this in a better. Let's not do the shortcut. So this gives you the number of no, that means you did not do this part. So you said what again? Did you say two? What are those two examples again?
I gave the example of $2.25.
Okay, $2.25, and you said it said $2.05, or did you mean like?
Yeah, if you don't subtract it, it would say your output would be $2, and then the amount of quarters would be
Be
5
of the
quarters.
full amount. It means okay.
Yeah.
Okay, let me get this out of here. And it's so then you'd be missing this statement here. So if you run this one, I mean, it looks like this maybe. Let's do 125.
Right.
Yes, yeah, and that would be because after you figured out the number of dollars, you didn't subtract those out of this intermediate value here. If we go to do something like this,
Oh, so okay, I see. Directly after you create the
yes,
number of dollars variable, you also want to update the input
exactly,
mod 100. Oh,
And
yeah,
here
afterwards.
you're doing again mod 25, and here you're doing it mod 10. Although we express it the shortcut way, let's not express it the shortcut way. And here, same thing. And then that's it. This is the number of pennies.
That way it updates the value every single time it goes through the code.
Yes.
Okay.
Yep.
Okay, thank you very much. I was having trouble with that.
All right. Okay. Well, good. So my offer's still out there. If there's any other ones that you want me to go over, these are good. These are on the surface they're confusing, but you know you sort of these are these little tricky things that you learn in programming, and then you're going to use them for forever. So, all right. So I will see you all Thursday.
Thank you.
Thanks for watching.